In this chapter on miscellaneous TLS topics, we reached the lesson that will present how TLS can be used without any X.509 certificates. Using TLS without any X.509 certificates may sound to some like a trickery or a hack, but it's not, as using TLS without certificates is a TLS feature that may be lesser known, but is a feature that was built into the TLS specification from the very beginning. TLS 1.2 can now be used without any X.509 certificates by making use of pre-shared keys. On the left side, you can see how a TLS 1.2 handshake looks like in case of using pre-shared keys without any certificates. As always, the client starts the handshake with a client hello message sent to the server. In this client hello message, the client then suggests a cipher suite that specifies the use of a pre-shared key either for both the key exchange and the authentication, or the client suggests a cipher suite that specifies the use of a pre-shared key only for the authentication, with an additional ECDHE key exchange taking place on top. The server then first responds by sending its server hello message. In case the TLS connection is a pre-shared key only TLS connection, the server may optionally send a server key exchange message within which the server can suggest a pre-shared key to use for the connection. However, it's then the client that with its client key exchange message indicates which pre-shared key to use, and in case the server doesn't know about this pre-shared key asked for by the client, the server will raise an alert and the TLS connection would be closed. Now, in case an additional ECDHE key exchange is conducted, then both the server key exchange message as well as the client exchange message are sent, which contain the respective ECDHE half keys of the client and the server. After the key exchange messages were sent, the client and the server then send each other their respective finish messages. Importantly, no X.509 certificates have now been sent, neither by the server and neither by the client. As such, in this TLS connection, no authentication took place so far. However, the finish messages exchanged by the client and the server at the end of the handshake now contain a value that's derived with the pseudorandom function pref from the master secret and a hash of all the handshake messages. As the master secret is derived from the pre-shared key used in the connection, knowing a correct master secret then proves knowledge of the pre-shared key. Thus, sending correct finish messages then authenticate the server and the client involved in the connection. This is how TLS 1.2 can be used without any X.509 certificates involved. Importantly, the use of pre-shared keys has now some caveats associated. These caveats, however, I discussed in a previous lesson of this course dedicated to this topic, so please have a look there to understand what caveats are associated with the use of pre-shared keys. For TLS 1.3, the story is quite similar to the story of TLS 1.2, and TLS 1.3 can now also be used without X.509 certificates by making use of a pre-shared key. This time, in TLS 1.3, the client immediately has the chance to send the server a label of a pre-shared key to use in its second message. Again, if the server doesn't know about the pre-shared key asked for by the client, the server will alert and the connection will close. However, if the server knows about the pre-shared key asked for by the client, the server will then acknowledge this pre-shared key in its second message returned to the client. Now in TLS 1.3, the pre-shared key can then again be used just completely by itself, in which case the pre-shared key is responsible for both the authentication of the peers as well as the agreement on the master secret, but the pre-shared key within TLS 1.3 can also be combined with an ECDHE key exchange. In case an additional ECDHE key exchange takes place, both the client and the server additionally send each other their respective ECDHE half keys. Again, up until the stage just before the finish message, no X.509 certificates have been used in the connection and no authentication of the peers has been conducted yet. The authentication of the peers then takes place by the client and the server sending each other the finish messages at the end of the handshake. These finish messages within TLS 1.3 contain an HMAC tag calculated across a transcript of the entire handshake, and the HMAC keys used are keys derived with the HMAC-based key duration function HKDF from both the pre-shared key and the optionally added ECDHE half keys exchanged. As such, a finish message that contains a correct HMAC tag then proves knowledge of the pre-shared key. Again, importantly, the use of such pre-shared keys has caveats associated. These caveats I discussed in a previous lesson of this course dedicated to this topic, so please have a look there to understand what caveats are associated with the use of pre-shared keys. With this, I close the lesson on how pre-shared keys allow to use TLS without any X.509 certificates.